Right, we are going to get started with project 1439, the belt tightener. And this is your first multi-component assembly. And you have 2 weeks to complete this, so don't freak, but don't wait until the very last weekend to try and get it all done either, because it's quite a bit of modeling to go on here and then lots of drawing documentation. And it is a metric drawing, so start with a standard millimeter template file. And we're going to start off with part number 1, which is the kind of the H-shaped frame. And I think that the best way I think to model this is to create one side of that frame and then mirror it, and then extrude the I-shaped center portion to both sides of the frame. So I want to model that one, and because I want to keep things symmetrical about my axes, I'm going to start by creating a new vertical work plane that's offset half the distance between the two. So the distance between the frames is like 70. So we're going to offset from our YZ plane 35 millimeters. And then we're going to start a new sketch on that work plane. Now, I'm going to warn you, as you're working through this project, because it is a metric project, you're going to have to be aware of your view cube flipping or rotating. So you just need to be aware of that so that you're not messing up on something, okay? All right, so let's start with the top cylinder. And I'm going to center it at my axes, and that has a diameter of 48. All right, and it should be fully constrained. And so I'm going to flip back around here so I can see. And I want to extrude that to the right side, the thickness 25. Okay. And then, let's see, that work plane didn't make it auto resize. Now I want to do another sketch for the lower cylinder on that same work plane. Circle. Come on, there we go. And this one at the bottom, 32. All right, and let's line these things up. Oops. I forgot I'm not. There we go. And we'll go with a dimension down. That is 140. And we want to extrude that. And it is 19. Okay, so that's got that part done. Now what we want to do is we're going to do 2 sketches for the ellipse because this is going to be a lofted feature. And so we'll put our first sketch here in the center of this cylinder on our XZ plane. Right, yep. And so let's slice our graphics, and I'm going to rotate it around a little bit, make it a little easier to see. Okay, because of the way the ellipse tool works, I need a center point and an end point. So I'm going to draw a construction line through this, and I don't want it to be in the center of the thing. I don't want it to snap to that, but I want it to snap to both of the endpoints, and I want it to be perpendicular. Come on. I'm not getting, there we go. Okay. I should have. Okay, I was worried about that. All right, so let's change our circle over to an ellipse and choose the center point of that, the end point, and the width would just make it something, but don't snap it to anything. Okay. Now this this is the center of our part over here, and so if you look in the left side of the part, you can see it's offset in 3 millimeters from the inside edge, and the thickness of the ellipse is 12. So we need 2 dimensions here. We need, and the funny thing about dimensioning ellipses is you don't really get much of a choice. So we get a minor radii, and so that's going to be 6. And then to dimension from the inside edge over to it, it snaps to the center. So that's going to be 3 plus the 6. Okay, so it's the edge of the ellipse is 3 millimeters in from the inside face of that. Okay, so let's finish that sketch. And now we'll do a work plane down to here, and then you'll do the exact same thing over again. And I'm going to pause. There's no need for me to show you to do it twice. Okay, if you had trouble with your ellipse sketch, it could very well be when you drew your construction line down, that it did not put a coincident constraint at the bottom of the cut plane. So you may have to project cut edges to be able to get that coincident constraint there. All right, so now we got our 2 sketches. We're going to do a loft, and I'm going to click to add here, and I'm going to come over here and click the sketch names. I don't know why that is so weird that it won't do that now. Huh. That was, but it's just picking up the point. Huh. Really weird. It worked before, and I could just pop it right in there. Okay, so let me make this a little easier. I'll change to wireframe so I can see them. Now we'll go back and go loft. Click to add a sketch. Why? Oh, did it? Oh, I see. I see. I didn't turn off construction lines. Dummy me. I feel so, there. I feel so intelligent. Okay, so now I can pick them. All right, and then you get a preview of your ellipse loft there. Okay. Now let me change my view back. Okay, so that's got that thing. And looking at it from the front view, you should see that kind of an offset. Okay, now we can put the hole in the bottom, but we don't want to put the hole in the top because the holes in the top are 2 different sizes. So you can do the hole in the bottom. I don't have to show you. You can do the hole down here. I don't have to show you how to do that. We can do the fillets on this with no problems because the modeling is pretty much done. Just be aware that the fillets down here around right there are 1.5. All of the rest of the fillets are a 3. So go ahead and put the hole in the bottom and fillet this thing up, and then we'll catch back up. Okay, so your part should look something like this now. And we're going to mirror it about the YZ plane. And when I go to mirror it, if I just choose mirror solid, it automatically picks the whole thing. So I'll go mirror plane and go to my YZ plane and go OK. And so there we've got that. All right, so let's see. We got that. All right, I want to create a work plane to do this kind of an I-shaped thing across here. I think the easiest way, because if you just do a sketch here, you can't project geometry of an ellipse because the whole thing is rounded. So we need to create a work plane that goes through the center of the ellipse. And if you remember, we created this work plane 1, and it's 9 millimeters over to the center of the ellipse. So I'm going to do an offset from work plane 1, 9 millimeters, and do a sketch on that work plane, slice my graphics, and go project cut edges. All right. Now we're going to sketch this I-shaped thing, but we're going to use the slot tool. It just speeds things up. Doesn't matter which one you choose. We'll just go with this one. And I'm going to put 2 slots in. Okay. And what we'll do is we'll go ahead and make them tangent to the outside edges. That's okay. Doesn't matter. We can apply the thickness of them. The book shows us an overall thickness of each part of the Y, so we can dimension a radius. And it's not 4.29, you know that. Okay. Now we know, let's see, we have a dimension up to the bottom and then a dimension from the bottom of the eye to the top of the eye. So we can go with a dimension there to there and a dimension from there to there. Okay, so we've got those dimensions. And once you put in your correct values for that, then we'll draw a rectangle. Excuse me. We'll draw a rectangle here in the center, or 2 connecting lines, doesn't matter. 2 connecting lines is actually easier because of constraints. So get your correct dimensions in for these things, and then we'll move forward. I got my dimensions in, and honestly, I've done it both ways with the rectangle, and I think lines gives you fewer deals because you can automatically get a vertical constraint when you do the lines. And get them perpendicular, but when we did the rectangle, it loses some constraints. All right, and so we've got a thickness, an overall thickness, and a centered thickness. All right, once you get it dimensioned in there, we'll do a trim. And we're still fully constrained. So that's golden. All right, so let's finish our sketch and extrude it. And we want to make sure you get the whole I shape. And we're going to change directions and go to next. Not through all. 2. There we go. That looks beautiful. That looks great. All right. So let's turn off that work plane. Okay, what we got next? Okay, so the hole up here is just a standard 22 millimeter hole. You can put that in. Fillets, the rest of the fillets on this part, well, we should have all, oh, we got the fillets in here. So we got all the fillets in and around this thing, and even the bottom surface has fillets, okay? So you want to get all of those in. I'm gonna pause the video, do those things, and I'm gonna come back and we'll do the keyway. Okay, so I got my fillets in, got my hole. And like I was saying, fillets, this thing is filleted all the way around on the inside and across the bottom. Now it's time to put in the keyway hole and slot, and I apologize. I got all the way through this and several other parts and was working in the assembly and noticed I had an error in my keyway. So that's why my material has changed all of a sudden in the middle of the video as I'm coming back and editing this. So to put in the keyway, easiest way to do this would be to create a sketch on this surface plane, and then we'll slice our graphics and come in and do a concentric circle out of there, and it is a diameter of 16. And you could certainly draw a rectangle and trim it out, but I'm constantly running into problems with rectangles becoming unconstrained. So what I want to do is just pop in. I mean, yeah, we could put in the values. It's a 1.7. Now we're going to run into an issue. Yeah, I didn't want to do that. It's easier if we don't dimension it to start with. But constrain it on the circle, vertical, horizontal, and then back down onto the circle. And then dimension. And do a vertical constraint to the midpoint. And then dimension 1.7 and then trim. And we are fully constrained. So we'll extrude that with a cut through all. All right. And I got the keyway in. Now, you're going to want to apply materials. Of course, this one is a cast iron. And we had polished or chrome polished on the finished surfaces, and we need to grab the inside of the keyway, also the slot, and we'll make them chrome. And you can see I've already got several of those done. And then the drilled hole sections, we are doing polished, brushed. And I think that gives it an appearance of being drilled anyway. So you'll want to finish up those, okay, your material faces properties. And then something new I want us to start doing is go to eye properties, and in the summary, put in the name of the part here in the title, and that will populate it in the parts list. When we create our parts list, it should bring that in. So we'll type in frame and then save it. Of course, I've already saved this once. You're going to save it as 14-39-1. Of course, I'm putting vid in front of everything I'm doing for the video. So all of your parts will be 14-39- whatever the part number is from the textbook. And that gets this thing done here. So if you got questions, shoot me an email, come see me.